Hello, welcome to this video which demonstrates how to use the built-in HealthCheck functionality which is available as part of ASP.NET Core. To demonstrate this, I've just put together a simple application which allows a user to change their password. So, like many other password forms, you enter your new password and you confirm it, and then you click Change Password, which then updates your password on the database. So for security purposes, we're using a third-party service to make sure that when the user enters a password, it's not a common password that's been seen in a previous data breach. A good example for this would be the word password. Which then isn't allowed because that third-party service has said that's been seen previously. If, however, we pick something that's random, so the easiest way to do this for now is just to generate a GUID. Then we know we're fairly unlikely that anyone else has used that password, and it gets correctly updated from the database. We look at the code, we can see it's a Vaser Pages application, and all the code for this sample application is in the index file. So we check the password and the confirmed password fields match. We then use Troy Hunt's own password service to see whether the password's been seen on a data breach or not. Assuming we're okay, we then go and find our user record from the database. For this example, we've just hard-coded the username. We then hash the password using bcrypt to make sure we're not storing it in plain text on the database. And then finally, we can then update the database using an entity framework. So that's okay, all straightforward. But then you could imagine a scenario where that program's been put into production for a couple of weeks, and then a member of your IT department or a service reliability engineer comes up to you and says, "That's great, but we need to add this to our monitoring software because this is such an important program. We need to know when the system's going down." The easiest way to do that is to use the new built-in HealthCheck functionality. So you go into our startup file. So like any other services, we can just add it in at this point here. So we can say services dot add HealthChecks. And as a minimum, that's all you need to add for the services, and then the endpoints. Something similar, but you also need to give it the URL which your monitoring software is going to hit to check to see whether your site's working or not. So I'm just going to have HC for HealthCheck. Now we run our site. Once it starts. So it's still running as before, but we can see we've now got a new endpoint called HC which returns healthy. So then you can point your monitoring software at this endpoint, and as long as it's returning healthy, the monitoring software is going to show green and your site's up. So that's all very well, but then we can see that the site's up. What happens if one of the services used by this site goes down? For example, what would happen if we now went and took the database offline? So I'm just going to run a script I've already written, which disconnects any current user in the database and then sets it offline. So our HealthCheck is still returning healthy because the site's up, but if we try and change our password, let's pick a new password. As you would expect, this is going to fail because it can't connect to the database. So what we can do is we can extend our HealthCheck further. So if we go to this site here, in this package here for ASP.NET Core Diagnostic Health Checks, you can see they've got additional checks for other third parties. And in our case, we want to do an extra check for SQL Server. And we can actually use, because we're using Entity Framework, so we can actually check that. So we want to install our package, which this one here is the diagnostics check for the Entity Framework Core. And then when we add our HealthCheck service, we can then also add a DB context check, as that's coming as part of the package. So this check here will actually check it can make a connection to SQL Server. It doesn't actually run a proper query. I think it just checks it can log in. So if we now check our endpoint now, see our endpoint says it's unhealthy because it can't connect to SQL Server. We start SQL Server up and running again, so we'll bring it back online and allow people to log in. We can see it then gets to healthy. So your IT department might come back and go, that's all very well, but what happens if our third-party pwned password service goes down? How are we going to detect that? So we can simulate that going down by blocking it on our firewall. So this is going to block all outbound HTTP traffic. So as you'd expect, our health checker still works, but if we try and change our password, that's going to fail because it can't connect to the service. So because this isn't a built-in check, we're going to have to write our own custom check to check this service. We look at the code of the service. All it's doing is using HTTP GET request. So we just need to check something similar to that. So we'll create a new class. We'll call it. Oops. So that has to inherit from an HealthCheck interface. Okay, and we're going to implement it in sort of quite a simple way for here, but you might want to do something a bit cleverer with the HTTP endpoints, etc. in real life. So create a new client. Set its address, which I will just copy from my notes. And so then what we're going to do is we're going to try and connect to that. So we're just going to try and check any old password, it doesn't matter what. And we'd expect that to come back successful. We don't care whether the password's been seen before or not, we just want to make sure the call's successful. And assuming that is successful, we can then return a health check result of healthy. If, however, this has failed, then we're going to have an exception, and so we want to return a health check result. And so let me overload. So status. Unhealthy, and we can say well, we don't need a description, but we can give it the exception as well. We do need a description. So that's reasonably straightforward, and then we just hook that up as well in our startup class, same way as we did with the DB context check. So this time we're just going to say add check, and we give it a name, pwned passwords. and we give it an instance of the class that's going to do the check. And passwords health. So we can check to see if that works. So we've currently got the status of unhealthy. If we remove our firewall rule, it's now healthy. So that's great. So that's met that requirement of your IT department. You can now check whether any of our external services are down, either the database or the phone password service. However, your IT department may now come back and go, it's all very well, we can see whether the site's up or down, but we want a bit more detail. We want to know which of these services is down. So the way you can do that is you can actually customize this output. So to do that, you have to install another package. This time it's the HealthCheck UI client package, and then in our startup code we can extend our endpoint here to actually give it a format. So it takes a second parameter, which is some options. This is a stop money. And the one we're going to be interested in is the response writer, because that allows us to customize the format. We can use one that's provided by this package. UI response writer. Right. Check. Response. I think I probably need to add a using statement. So we want to use I have to look at my notes. I didn't save it. Okay, so that's using the built-in format provided by that package. So if we look at our endpoint now, so we now get a bit more detail. We now get a JSON response which tells us overall is healthy, and it also shows us the individual services we're checking, which are also both healthy. If we now go and stop our traffic, we now see the overall status is unhealthy because at least one service has failed, and we can see the phone password checks failed, and it's got a description from our exception, and the DB context is still healthy. If we take our database offline, we can see that now becomes unhealthy as well. So the IT department should be quite happy with that, but then they come back with another issue they found. They say it's all very well this, but when the service fails, it's returning a status of 503, which means the site's down, which is true. But unfortunately, our monitoring software really needs to have a 200 code, so we can then pass actually the description. Fortunately, we can customize that as well. In here, we can actually specify what our response codes are going to be. So we can say response status codes equals, and then for each of the possible cases, so we can do health status dot graded, which response code would we have? So in our case, we're now going to have status codes of 200 for everything. So now our checks should still be failing, but we will be getting a 200 response. And if we now make our checks pass by allowing the traffic and re-enabling our database, you can see we still get a 200 response back. So as you can see, it's quite easy to add HealthCheck support to your application, and this is just a sort of a taste of the number of features which this library has available. You can do things such as readiness checks and liveness checks. You can have it so it pushes out the data to your monitoring software instead of it pulling it, and you can also have its own built-in UI, which I'd recommend if you're going to do that to put it in a separate application. Thank you for watching.